Hi guys, in this video we are going to solve the problems of chapter 4.5. The title is find both a basis for the row space and a basis for the column space. Okay, first I give a rough introduction about what is a row space. Row space, so if there is a matrix A with order m by n, there will be n columns and m rows, isn't it? And all the rows of this matrix can span maybe a subset of r power n rows, isn't it? And columns may be subset of r power m. So the rows in this out of this n m rows, there are some independent rows that will span some subspace from r power n. So we are going to find the number of rows that span a subspace of r power n. Okay, that's what our row space. For row space we are going to find as basis in this problem. Let us start. The first problem is this matrix we are going to reduce into row echelon form. The formula that we are going to write here is to convert this a11 into 1 and other two elements into 0. So first rule I am going to write is r1 is r1 minus r3. So that will change the matrix into, see, r1 5 minus 4 1 2 minus 1 1 4 minus 5 minus 1. There is no change in the second row, no change in the third row. Okay, the next step we will do another formula for r2. We want this element to be 0, 2 to be 0 and 4 to be 0. Let's write formulas for that. r2 is r2 minus 2 r1 and r3 is r3 minus 4 r1. When we use these rules here, there is no change in the first row. Second row, these elements will be 0. Now use here r2 1 minus minus 2 1 minus 2 times 1, isn't it? It will be minus 1 1 minus of 1 minus of minus 2, so plus 2, it will be 3. And the third row, it will be minus 3 here and 5 minus 4 is plus 4 is 9. So we will get this matrix. It's not still reduced, isn't it? And we want to convert this negative 1 into positive. So row 2 will be row 2 multiplied by minus 1. No change in the first row. 1 1 minus 1. Second row will be 0 1 minus 3. Third row will be 0 minus 3 9. You see, we want to convert the elements the above. So this is the leading element of the second row. The above and below elements should be converted into 0. Let's try now. Formula r1 can be r1 minus r2 and first let's solve this one. No change the second row. 0 1 minus 3. This is 1. This element will be 0. Now r1 is minus 1. Minus of minus 3 will be plus 3. It will be 2. The formula for r3 is r3 plus 3 times r2. So this element already 0. This will be 0. Here r3 is 9 plus 3 times minus 9 is minus 9. It will be 0. So the entire third row became 0. So this row is irredundant. Okay, and now we get two linearly independent rows in the reduced matrix. This is a row echelon form. Now row basis we will write here. Row basis will be the set of all the first two non-zero rows 1 0 2 and 0 1 minus 3. This is row basis. When we want to write column basis, we need to pick the columns that have, we need to identify the columns that have leading element, that the first column, second column, and go to the original matrix. From original matrix we need to pick first two columns, because here we are performing elementary row operations. So the resulting matrices may be equivalent to the original one in rows, but not in the columns. Columns are not equivalent. So from the corresponding rows of the leading element, we will find columns, and corresponding columns from the original matrix should be picked for column basis. So the first column is 5 2 4, second column will be 2 1 1. That will span a subset of R power 3, subspace of R power 3, right? So our column basis will be 5 2 4 and 2 1 1. So the row basis has two elements, column basis has two elements. We can write row rank and column rank, both are equal to 2, which is rank of the matrix, and total number of variables n is equal to 1. Therefore nullity will be 3 minus 2, the dimension of the null space, which can be a solution space if this is the matrix of body matrix of system of equations, homogeneous system of equations, right? That is the end of this problem. Actually in this question there is no row rank, column rank required. We can stop at row basis and column basis. We will try the same work in second problem. Okay, second problem we will try now. Well, the same work we are going to do in problem number 11. Already the leading element in the first row is 1, so we need to convert the same column elements into 0. Let's write a formula. R2 is R2 minus 2R1, R3 is R3 minus 2R1, R4 is R4 minus 3R1. Okay, then the resulting matrix, there is no change in the first row, 1 1 3 3 1. Second, this column elements will be 0, and it will change this. R2 is R2 minus 2R1 will change the second row into R2 3 minus 2 times 1, so 1. 7 minus 2 times 3, 7 minus 6 is 1 again, and similarly you can fill the remaining parts. Similarly third row, R3 is R3 minus 2 R1, so this is 0 1 1 2 1, and the last row will be R4 minus 3 R1. R4 is 3, 3 minus 3 will be 0, 1 minus 3 will be minus 2, and next minus 2 minus 4 1. Have you noticed here the rows are subspace of R power 5 here, and columns are subset of R power 4. So rows are going to span a subspace of R power 5, and the columns are going to span a subspace of R power 4. So for this subspace we are going to find the basis right now. Okay, so number of linear independent rows, linearly independent columns. Well, we finished the first column. Second row leading element is 1. Here it's already 1, and above and in the column elements should be converted into zeros. So we will write the formula for that. Formula is R1, see this one, R1 is R1 minus R2, R1 minus R2. So what is happening? No change the second row, 0 1 1 2 0, isn't it? First row, because of this formula, first row will be 1 minus 0 1, 1 minus 1 0 3 minus 1 2 1 1 minus 0 1. Formula for third row R3 is R3 minus R2. So 1 minus 0 minus 0 1 minus 1 0 0 0 1. Formula for row 4 will be row 4 R4 minus or plus, you can add, isn't it, plus 2 times R2 will be 0 0 minus 2 plus 2 again a 0 4 minus 4 plus 4 will be 0 1 plus 0 will be 1. So the last two rows are identical, one of them can be 0. We can write a formula to make this element. See, this is our third row, leading element is 1 here in the extreme end. So we want to make the above and below elements, the column elements, to be 0. So formula for R1 is R1 minus R3. No change the second row, 0 1 1 2 0. Third row 0 0 0 0 1. First row will be 1 minus R1 minus R3. 0 minus 0 2 minus 0 2 1 minus 0 1. Finally 1 minus 1 0. The last row R4 will be R4 minus R3. So 0 minus 0 0 minus 0 0 minus 0 0 1 minus 1 0. So only 3 non-zero rows we got. Therefore row space, now we will write row basis. There are 3 non-zero rows, all from R power 5. 1 0 2 1 0 first vector, 0 1 1 2 0 second vector, third vector 0 0 0 0 1 third vector. So there will be a subspace in R power 5 which are spanned by these 3 elements. This will be the row rank. Row rank will be 3. Now column basis. See, the first column has a leading element, second column has a leading element 1, and the fifth column has a leading element 1. All the columns are subsets of R power 4, isn't it? So we will go to original matrix and pick the first, second and fifth columns. That will be this column basis, which is first, second and fourth. We will write them. Column basis will be 1 2 2 3, the first vector. Second vector will be 1 3 3 1, the second vector. Third vector, fourth fifth column 1 2 3 4. They are members of R power 4. So this this is the basis which spans a subspace of R power 4. This is called column basis. The next question will be slightly different. This is the question. The question says that a set S of vectors in R power 4 is given. So there are 4 vectors from R power 4. Find a subset of S. From these 4 vectors, we are going to find a subset, maybe combination of 2 or 3 or maybe 4 vectors that form a basis for the subspace of R power 4. So out of these 4 vectors, how many are linearly independent vectors? Then that will be a subspace, a basis for a subspace. Okay. So we got to do the same task again, reduction into row echelon form. Let's start solving this one. Okay, solution. Now write all these vectors as a column or matrix. Okay, 1 minus 1 2 3, second 2 3 4 1, 1 1 2 1, and finally 4 1 8 7. You see, we don't want a row space here. Actually, they are looking for a column basis. Out of these 4 vectors, we want a subspace. So after reducing the row echelon form, depending upon the leading element column, we will pick the vectors from here, right? That's the plan here. So this is just column basis we are going to find, for which we need to figure out leading element in every column by reduction method. Okay, the leading element in the first row is 1. We are going to use elementary row operations. So first element is 1. The column element should be converted into 0 by choosing appropriate formula. Let's write the formula here for R2 plus R1. So what happens in the second row? There is no change. The first row 1 2 1 4. The second row will be plus sum them, that is 0 5 2 5. Third row formula R3 is R3 minus 2 R1, R3 2 minus 2. So 0 here, 4 minus 4, 0 2 minus 2, 0, all zeros, 8 minus 8, 0. Formula for R4 will be R4 minus 3 times R1. This is 0, 1 minus 6 minus 5, 1 minus 3 minus 2, 7 minus 12, so minus 5. Identical to row number 2, isn't it? Can we make it 0? So R power 4, the new row formula is R4 plus R2. No change in the first row, 1 2 1 4. Second row 0 5 2 5. Third row is a 0 row. Fourth row becomes a 0 row. Now we need to convert the second column element into see, R2 can be R2 divided by 5. What we get is first row 1 2 1 4, second row 0 1 2 over 5 1, third row is a 0 row, fourth row is also a 0 row. And to find a column basis, we don't need to we just need leading elements in every row. That's all. We don't need to convert it's enough to get a diagonal form, upper triangular form, isn't it? No need to convert the above elements into 0. We just pick corresponding column vectors from the original matrix. So we have leading element in first column, leading element in second column. If we figure out the leading element, we can go and pick from the columns. There are only 2 independent linearly independent rows, so there will be 2 independent columns. First 2 columns have leading elements. Go back, V1 V2 will form a basis. So here this element not necessarily be 0. We don't need to wait to convert this element to 0. It is enough to identify leading elements in every row. Okay. Now from the original matrix, we know that V1 and V2 form a basis for the subspace of R power 4. So the basis is 1 minus 1 2 3. So first vector 2 3 4 1. These 2 vectors span a subspace of R power 4 for this problem. And the next problem, we need to solve this problem as per our syllabus. Okay, find a basis T for R power 4 that contains the vectors V1 and V2. You know that R power 4 is a 4-dimensional vector space. So in its basis, if you find basis T, there will be 4 vectors. And 2 vectors have been already given. The question is, what are the remaining 2 vectors? The fundamental basis for R power 4, there will be 4 vectors. 1 0 0 0 So the basis of R power 4, we know that there are 4 vectors. They are E1 1 0 0 0, E2 0 1 0 0, and E3 0 0 1 0, E4 0 0 0 0 unit vectors, isn't it? And I include these 2 vectors v1. So out of these 6 vectors, we need 4 independent vectors. That's all. Then T will be a basis for R power 4. So every set of 4 vectors which are linearly independent will be a basis for R power 4 as per the theorem, right? So we are going to use v1, v2 and all this E to form a matrix, and then again we do row echelon form. So let's write the matrix A here. First vector v 1 1 1 1, all are units. Second vector will be 2 3 3 3. Now all unit vectors 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So we have selected all the vectors in the matrix as a columns. Now we are going to use the row echelon. We are going to reduce the matrix into row echelon form using elementary row operations. This leading element is 1. Convert the other elements into zeros by choosing appropriate formula. Formula for R2 is R2 minus R1. So no change the first row 1 2 1 0 0 0. Second row will be 0 3 minus 2 1, isn't it? 3 minus 2 1, and 0 minus 1 minus 1 1 minus 0 1 0 0. Formula for R3 is R3 minus R1, and these 2 elements will be 0 if you write formula for R4 as R4 minus R1. Third row will be 3 minus 2 1 0 minus 1 minus 1 0 minus 0 1 minus 0 0 minus 0. Fourth row will be 1 minus 1 0 0 0 minus 0 0 minus 0 1 minus 0. That's it. Now second row has a leading element 1 here. The column elements should be converted into 0, right? Well, let's write the formula for R1. The formula is R1 minus 2R2. Second row has no change, 0 1 minus 1 1 0 0. This formula will give you row 1 as 1 0 3 minus 2 0 0, and for row 3 the formula is row 3 minus row 2. That will be, this is already 0, so here 0 1 minus 1 minus 1 0 0 minus 1 1 minus 0 0 minus 0. For R4 the formula will be R4 minus R2. You get all zeros here, 0 minus 1 0 minus 0 1 minus 0. Now the third row, the leading element is negative 1. We can just multiply, isn't it? Row 3 is row 3 times minus 1. We'll change the row 3 into 0 0 0 1 minus 1 0. No change in the other rows. 1 0 3 minus 2 0 0 0 1 minus 1 1 0 0 0 0 0 minus 1 0 1. Okay. Now using this leading element in the third row, convert the column elements into zeros. Convert the column elements of that leading element to 0. So let's write the formula for row 1. Row 1 will be row 1 plus 2 row 3 No change in the third row. 0, 0, 0, 1, minus 1, 0. So first row will be 1, 0, 3, 1, 0, 3, 0, minus 2, 0. Second row formula will be row 2 is equal to row 2 minus row 3. So this 0 minus 0, 0 minus 1, 0 minus 1, 0 minus 1, row 2 minus row 3. 1 minus 0 is 1, minus 1 minus 0 is minus 1, 1 minus 1 is 0, 0 minus 1 will be 1 and 0. Finally the row 4 plus row 3, just add 0, 0, 0, 4 zeros and minus 1, 1. We have leading element in every row. First row, second row, third row, fourth row. We have fourth row. We want it to be 1. We want it to be 1, isn't it? Multiply by minus 1. So R4 will be R4 times minus 1. There is no change. The first row 1, 0, 3, 0, minus 2, 0. 0, 1, minus 1, 0, 1, 0. No change. The second row, third row will be 0 multiplied by minus 1 or 3 or 4. No. 3, 0, 1 minus 1, 0 third row, and fourth row will be the new row 0, 0, 0, 0, 1 minus 1. And at the end, the fourth leading element in the fourth column is 1. The same column element should be converted into 0 by using this leading element. Their formulas will be written here. R1, we want R1 plus 2 R4. So row 1 becomes 1, 0, 3, 0, 0, minus 2. Second row formula will be row 2 minus row 4. So 0 minus 0, 1 minus 0, minus 1 minus 0, 0 minus 0, 1 minus 1, and 0 minus 1. Formula for row 3 is row 3 plus row 4. We can just add them. 0, 0, 0, 1, 0, minus 1. Fourth row remains the same. 4 zeros, 1 minus 1. So we got leading elements in all the 4 rows. All the 4 rows are linearly independent. We need a column basis. So 1, 2, 3, 4. No. 1, 2. The leading element is here, first column. Second column has a leading element. Third column there is no leading element, but fourth column is a leading element, and fifth column is a leading element. So the given two vectors v1 and v2, e1 is not in our list, so this is e2 and e3. These four are the vectors that span r power 4 and belong to T. So when we write T is v1, v2 from the given vectors, and e2, e3 is the basis of r power 4. That's the end of this problem. And finally we have one more problem in this chapter to be discussed. given a homogeneous system Ax is 0 of scalar linear equations, we say that a subset of this equation is irredundant provided that the corresponding column vectors of the transpose A power t. So we need to pick the A power t from this A matrix, and we check uh, the linear independence by reduction method. Okay, so A matrix from the given problem is 1 2 4 minus 3 3 minus 3 2 2 6. In problems 21 24, extract from each given system a maximal subset of irredundant equations. Okay, so we are given that the transpose A power t are linearly independent. So let's take A transpose matrix here and reduce it into row echelon form. 1 minus 3 2 2 3 2 4 minus 3 6. This is what we are going to reduce. So write the formula. Already leading element in the first row is 1. Formula for row 2 will be row 2 plus 3 times row 1. Okay, using this numbers we will write the 4. And obviously for row 3 minus 2 row 1. When we use these formulas, this elements will be 0, and here no change in the first row. Row 2 3 plus 3 times 2. Row 2 plus 3 times row 2 is 3. 3 times 6 is 9, isn't it? Okay, what we get is this is 3 row 2 element is 3 plus 6 will be 9, and here minus 3 plus 12 will be again 9. For row 3 will be 2 minus 4 will be minus 2. 6 minus 8 will be minus 2. You can find here some identical rows are there. Row 2 is row 2 divided by 9, and row 3 is, we'll do row 3 later. Row 3, okay, row 3 divided by minus 2 will get you 1 2 4 0 1 1 0 1 1, and the third row can be easily converted into 0 by the formula R3 is R3 minus R2. 1 2 4 0 1 1 0 0 0. So first two rows have leading elements, so the first two rows are the linear independent rows. That will give you that first two equations are irredundant. First two equations are irredundant. That's enough. You don't need to convert this element into 0. We can stop here. The row rank is 2. So first two equations are irredundant. Third equation is redundant. Okay, so we can write here first two equations are irredundant. The first and second equations are irredundant. Okay, they are important, not a trivial, not unnecessary row. That's the end of this chapter. Thank you very much.